if one ignores dy over dx, you can easily identify a homogeneous differential equation. So if one ignores dy over dx, a differential equation is homogeneous if the sum of the powers of x and y in each term is the same. I've already explained that in the previous example. Now, for example, here, um, the powers of x and y here, the sum of the powers of x and y here is 2. Now, here is 2 and 2. And you can see that the sum of powers of x and y, um, here it's 2, 2, 2. So the sum is the same. All right. So therefore, this equation is homogeneous. The same thing, the same idea applies to this one here. So here it's 3, 3, because you have 1 plus 2, which is 3, 1 plus 2, 3. So the sum of the powers of x and y in each term is 3. All right. And we can see that. All right. So here we have 3. Actually, here as well. 1 plus 2, that gives you 3. All right. So 3, 3, 3. So that's how you can actually identify a homogeneous differential equation. Okay. Now, we are required here to solve, to find a general solution of this differential equation. So remember what I said initially? The first step is you multiply both the numerator and denominator by 1 over x to the power n, where n is the sum of the powers of x and y in each term. So multiply. All right. So what I just need to determine here is what's the highest power of each term here, which is 2. So I'll just divide by 1 over x to the power 2, both the numerator and denominator. So what I'll end up with is dy over dx will be equal to x squared plus y squared. All this multiplied by 1 over x squared over 2xy multiplied by 1 over x squared. Okay, and then I need to simplify that. So what I'll end up with is dy over dx will be equal to 1 plus y squared over x squared over 2y over x. So that will be 2y over x, which can be written as 2 into bracket y over x. Okay. Now, already I have it in this. Now I can write this as dy over dx is equals to 1 plus y over x squared over 2 into y over x. That's better. 2 into y over x. Okay, that's much better. Now, what I'll be focusing on is basically this guy here, so that I can be able to use the substitutions. So, on my right hand side here, I'm gonna say let y be equal to Vx, remember the substitution that we talked about in the previous example? Yeah. So what I'm going to do, Vx, so one term. So I know that this can be written as, remember, you can rewrite this as um, right here. You can say V is equals to y over x. It's the same thing. So what that means is my equation here can be rewritten as dy over dx will be equal to 1 plus v squared over 2v. All right. And I'm just going to put that in a box. We'll come back to that in a minute. So I just want to go back up here and kind of, I should actually try and move this down so that I can see everything that I'm working with. Somewhere there. No, right. All right, I'll just leave it there. So what I'm going to do is now to differentiate this and use product rule to differentiate this. So I'll end up with dy over dx will be equal to v d over dx of x plus x d over dx of v. So I'll end up with v plus so dy over dx is equals to v plus x dv over dx. All right, and this is another equation. So what I'm going to do next is to put these equations together, right? Equate these equations together. So what I'll end up with is I'll end up with v plus x dv over dx will be equal to 1 plus v squared over 2v, which I can, this is a separable differential equation, right? Now this is a separable differential equation. So you just need to separate the variables, okay? We need to separate this variable so that we have the x guys on one side and y guys on one side. So let's multiply both sides by 2v. So we'll end up with 2v squared plus 2vx dv over dx will be equal to 1 plus v squared. And then just simplify that. Remember, we have like terms 2v, and so that will be 2vx dv over dx will be equal to 1 minus v squared. And we can carry on, divide both sides by 2v. So x dv over dx will be equal to 1 minus v squared over 2v. And we can go ahead and separate the variables. So 2v over 1 minus v squared dv will be equal to 1 over x dx. Okay, and now after that we can integrate the left hand side and the right hand side. Now I want us first of all to consider this bit. So let me just write here, consider this integral. Maybe I should use red. All right, so the reason why I am saying let's consider this guy is we may have to use substitution to integrate this guy. So let m be equal to 1 minus v squared, all right, which means dm over dv will be equal to negative 2v, which means that dv dm over dv will be equal to 2v, so which means that dv will be equal to dm over negative 2v. All right. Now, which means that if we use those substitution, this integral will be the integral of so here we'll end up with this integral being the integral of 2v over m multiplied by the m over negative 2v, and this will be equal to the integral of negative 1 over m. I can take the negative out, which will be equal to negative ln m plus c, if you want to write plus c, which will be equal to negative ln. Now m was 1 minus v squared plus c. Now I'm just going to ignore that. Okay, ignore that. So, and I'll just focus on this guy here. All right, this is my solution. So anyway, now that I have that, I can come back here and say, well, this equation here, so this guy will be, so I'll end up with the integral. Okay, I need to check. So this integral will be equal to negative ln 1 minus v squared, which will be equal to integral of 1 over x, that will be just ln x plus c. All right, and we can carry on to simplify this. So this will be equal to negative ln 1 minus, remember v is y over x, so this will be y over x squared, which will be equal to ln x plus c. And we can carry on simplifying this, negative ln into bracket y squared over x squared equals to ln. Now, what I'm going to do here to write ln x plus ln a. So instead of plus c, we can write that as ln a. And let's just carry on simplifying this. On the left-hand side, we can write this as negative ln into bracket. Let's write this guy as a single fraction instead of having two fractions. So x squared minus y squared over x squared. And then here we'll have ln ax. Okay. Now, I need to get rid of that negative. So that will be ln into bracket. Get the reciprocal of that, because this is same as x squared minus y squared over x squared to power negative 1 is equals to ln ax, which is same as ln x squared over x squared minus y squared ln a. These guys do cancel. So what you end up with is something like this: x squared over x squared minus y squared, which is equals to a. Now we can rewrite this as I just need to check that I didn't. Oh, that's ax. Missed that. Ax So x. So we can rewrite this as x squared over ax is equals to x squared minus y squared, which can be simplified as x over a is equals to x squared minus y squared. Um, and we can rewrite this as, say, let 1 over a be equal to c. Then this bit will become cx is equals to x squared minus y squared. And therefore, we can say y squared will be equal to x squared minus cx. Okay, and this will be our general solution.